Hello everybody, we are in financial maths topic and this is our first video and we are looking at annuities MS F5. So annuities, I'll just quickly explain what they are, but they just involve regular deposits or payments or contributions of money that will gain interest because we're using annuities. So annuities can be used instead of compound interest or simple interest formulas. So some examples that you might find are loan repayments or just building up a sum of money in the bank as an investment. So something to keep in mind is that the future value of an annuity is the sum of the money that you put in, that you contributed, plus the interest that the annuity will earn you. So if we have a look at our first slide, we have annuities as a recurrence relation model. So annuities involve time periods, just as compound interest or simple interest involve time periods, but instead of putting it into your calculator, as you normally would, in annuities, you have to do it step by step for each time period. So there'll be multiple calculations. If there's 3 time periods, then you'll have 3 calculations, one for each time. So say I had $100 and I invested it in an annuity. So after my first year ended up as $150. So for my second year, I would start with $150, do the annuity, and I might end up with $200. So then for my third year, I'll start with $200. So that's what it is by step by step. So if we have a look here, we have 2 formulas. We have one for investment and we have one for loan. So the only difference between the two is here we have a plus symbol and here we have a minus symbol. So if we have a look at the loan one, if you have a loan, you want to pay it back. You want to minus money from the loan because you're paying it back. So that's why there's a minus there. You want the loan to get smaller. Whereas if your investment, you want to build it up. You want your investment to get bigger. So that's why you're adding your payment to that. So let's have a look at an example. So here we have to use the recurrence relation models to answer these questions. So sometimes, I'll show you the next slide. This slide here has a table. So sometimes they'll ask it in a table, but in this question, they're just asking it to do it step by step, not using a table. So if we have a look, construct a recurrence relation model to this loan in this form, where Vn is the future value of the loan after n payments. So let's go to this slide. So we have some room to draw, some room to write. And firstly, what we want to do is we want to rewrite down the recurrence relation model. So I'm just going to write that down. So for A, we have Vn plus 1 equals Vn 1 plus R minus D. So because we're repaying a loan up here, repaying the loan, we want to minus the payment. So our second step would be to substitute our rate into the formula. So to calculate the rate, we need to look at obviously we need to look at what the rate is. So the rate is 15% per annum. So if we have 15% per annum, that means it's 15% per year. But if we have a look, this annuity is going to be compounding monthly, which means she's going to be making monthly repayments. So instead of yearly time periods, these are monthly time periods. So this rate is not in the time periods we want. It's in years, but we want months. So to get from years to months, we just have to divide 15 by 12. So we have to do 15% divided by 12, or 0.15 divided by 12. So these two things with the divided by symbol or as a fraction are the same thing. And so that's going to equal our rate. So we can go and we can calculate what that would equal. And so get your calculator out and pop it in. 0.15 and 12. So our rate would equal 0.0125. So that's what we're going to substitute for where the R is in our recurrence relation model. And we know that the monthly repayment up here is this much. So that's going to equal our D. This is going to equal our R. But remember, our actual R is down here. So we can go and write that into the formula. So we have Vn plus 1 equals Vn times the rate. So it's 1 plus 0.0125 minus our repayment, which is 257.85. So that's what the recurrence relation model would be. So now we have been asked to use our calculator to determine or to find the balance of the loan each month. So this one is going to go in step by step. And so we need to keep this here, this formula, so we can calculate for 4 monthly repayments. So I'm going to erase this information here because I need room to write in for question B. So I'll just write that this here was A, so that's what we found in A. And now we're going to do B. So the first one to do for B would be to do year 1. So obviously after the first year, she will have, so the Vn plus 1, that will be the first year. So first year equals whatever we borrow. So we borrowed $1,000. So that's the first, that's what Vn equals. So that's the value after no annuities has been added to that. Times 1 plus 0.0125 minus 257.85. And that will equal, if you put it into your calculator, it will equal 754.65. So when we're doing our second year, instead of using 1,000, we have to use 754.65 because that is our new value. After the annuity has been added to the 1,000 and we've made our repayment, our new value was 754.65. So that's what we're going to use. And we do the same for the first year in the second year, except we use the different value. And this one's going to equal 506.23. For the third year, you would use 506.23 in the Vn. I don't have enough room, so I'm not going to write out the equation, but it would be the exact same as what you did for the first and second year, but instead of doing 1,000 or 754, you'd use 506.23. and that would come down to 250, sorry, undo 254. Oh, why is this doing 254? There we go. 0.71 after the 3rd year, and after our 4th year, we would have 254.71. It's going to be very close to 0, this one, because our repayment is 257. Minus 257.85. So we equal with 0.04. 0.04. Ah, 0.0. There we go, 0.04. So that's how you do the annuity step by step. So that's our first step. You calculate it with the original value of 1,000. Then for our second step, you calculate it with the value you got from your first year. 3rd year, you do the same, and 4th year, you do the same. And so that would be our answer for question B, this part here. For question C, we have been asked what is the balance of the loan after she has made 2 payments. Give your answer to the correct nearest cent. So after 2 months, the value of the loan is 506.23. And question D, is the loan fully paid out after 4 payments have been made? If not, how much will the last payment have to be to ensure that the loan is fully repaid after 4 payments? So if we have a look at our 4th payment, we are not at 0. So she has not fully paid back the loan. She has only paid back 257.85 minus 0.04. So she still has got 0.04 left to pay back. And so her last payment would be, I'll do a little arrow over here. If she has to repay the loan by making monthly repayments of 257, her last repayment would be 0.04 plus 0.04 plus 257.85. So that's how much her last repayment would have to be. And if you add them together, 257.85 plus 0.04, it gets 257.89. So that's how you do a recurrence relation model, answering questions just like this as they have put them out in words. And if we have a look at the next